ARM processor pipelining, titled as Understanding ARM Processor Pipelining, a Case Study Approach. Today we are going to explore the how pipelining improves the ARM processor in real world case study. By end of this video, we are going to understand the pipelining process, how it is utilized in ARM processor in smartphones, embedded systems and IoT devices. Now let's see the problem statement of this case study. Ritika, can you explain the problem statement of this case study?
Imagine a smartphone running multiple apps simultaneously. The processor must execute all the instructions quickly. Instructions should complete all the stages before the next one starts, leading to reduced efficiency and delays.
So Anandi, can you explain the design thinking approaches available?
Yes. Okay, now I am going to tell about the design thinking approaches. We can apply the design thinking approaches to solve this problem. The first is empathize. In empathize, we can understand the performance needs in modern applications. The second is define. In define, the problem is slow instruction execution in ARM processor. The third is ideate. In ideate, how we can overlap the instruction execution. And the fourth is prototype. In prototype, we are implementing a pipelining. And the fifth is test. In the test, we are going to measure the performance and improvements.
So Sona, can you explain the ARM processor operation in pipelining?
ARM processor typically uses the 5 stages. Each stages are passes through this 5 stages. The stages of fetches, decode, memory access, execute and write back. Here is an example, instruction 1, instruction 2, instruction 3. In instruction, first execute is fetch. Second instruction, when in instruction 1, decode is executed. In instruction 2, it will be execute fetch. So simultaneously it will execute. 3 instructions are executed and 9 cycles are reduced.
So Harsha, can you explain this process with a simple example?
Yes. So consider the example 5 instruction sets I1, I2, I3, I4 and I5. Without ARM pipelining, each instruction takes 5 cycles. So total pipelining is 5 into 5, 25 cycles. And with 5 stage pipelining, first instruction takes 5 cycles and each subsequent instruction completes in 1 cycle. So the formula is n plus n minus 1. If we consider 5 cycles as n, so 5 plus 5 minus 1, 9 cycles will be obtained. By this we can understand that using ARM pipelining, 25 cycles is reduced to 9 cycles, which is more reliable, and compared to other processors, these execute very faster and more efficient.
We are going to see challenges in pipeline. While pipeline improves performance, it also introduces hazards. Data hazards, when the instruction depends on the results of the previous instruction. Control hazards caused by branch instruction. And for last, the structural instruction, when the hardware resources conflict.
So Dilsa, can you explain the real world impact of this case study?
Yes, ma'am. Real world impact in ARM pipeline. It enables smartphone apps to run smoothly and real-time processing in IoT devices and low power consumption without sacrificing speed. ARM is dominant in mobile and embedded markets.
Now let's see the conclusion part of this video. So in this video, we understood the TT stages that are involved in this case study, that is operation of ARM architecture without using pipelining and with using pipelining. So without and with pipelining, we compared the instruction cycles of total execution time is reduced compared in other processor. So the ARM processor with pipelining will give a faster execution and it reduces the total number of cycles and it utilizes the throughput in higher efficient manner. And ARM processor with pipelining mostly used in embedded systems and IoT devices, particularly in smartphone devices. Thank you.